Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is an answer to a question from our community. We asked our community we asked you if you have any questions about test-driven development. And this is the first question we've got. Do we really need to test everything? Opinion on stubs and mocks. And this is a question by Jofla. And when I first read this question, I thought, oh, there's a lot to talk about here. First of all, I understand where the question is coming. I understand that if you see tests that are written against private methods, against getters and setters, against really boring code, you might really wonder, okay, what's the point of doing that? And the thing here is it's very easy to write tests that are not interesting, that don't cover really the important behavior of your system. And if there's any mindset that needs to change about writing tests, and it doesn't matter whether it's test-driven development or something else, the most important mindset is to focus on behaviors. And the best way to think about behavior is input, action, output. But you have to think about it at from a larger perspective. So if you look at let's say login screen, that would be a fairly self-contained thing where your input is a username and the password, and your output is this user authenticated or not. So mainly the thing is about, was this user authenticated? And then once you introduce, let's say first you have login and password, but then you might introduce other types of login, social login, single sign-on, and so on. The behavior is exactly the same, only the implementation is slightly different. And so in that case, the behavior will be, if I log in with Google and the credentials are correct, or whatever it is, the token is up to date and valid, then I can log in. So, and maybe there's another thing that needs to be said, that often the simplest behaviors that you look at today are behaviors that will become more complex in the future. So covering them today, even if they are the very simple ones and obvious, covering them today might prove in the future very beneficial, because we have something to start from when we build on top of that. So this is more or less a tangent on what type of things you might see when you are dealing with tests. And if there's one piece of advice that I can give you right away, if you are testing private methods, if you are testing getters and setters, forget about it. Think about the higher level behaviors. Look into behavior-driven development on how to define those. And try to think differently. Try to think at a higher level. And this actually relates with stubs and mocks, because once you think about higher level behaviors, it's more likely that each behavior will cover more classes, kind of clustered together, because you really don't care how the code is implemented. You don't want your tests to be coupled with your implementation. What you really want to have is tests that define the behaviors that you want, and then you are free to implement them in one class, in two classes, in 10 classes, in one method, in 10 methods, in one public method, in 5 public methods, or in one public method and 10 private methods. It shouldn't matter. What matters is to write those tests so that they are decoupled from the actual implementation. And particularly mocks tend to link you, tend to couple you to the implementation. This is something that is hard to understand, because there is a testing strategy that's very easy to do, which is you take one class, you look at all the collaborators, you test this class in isolation, replace each collaborator with a stub or a mock, and you have your tests. And that is a very simple strategy, and it works because you can put in the center each class. But the problem with this strategy is that you need to pay attention that the stubs and the mocks are in sync with the real implementation. If you change something in the collaborator, it needs to change in the stub or the mock. And so you create more work for you. And probably a better way is to the one that I've discussed about. Think about behaviors as thinly sliced as possible, and then it doesn't matter on how many classes or methods they go through. But this leads us to another question, and the question is, how do we cluster those classes? And the current answer is not satisfactory, because we either have namespaces which don't have a strong boundary. We have libraries which kind of have a strong boundary, but they are not as easy to use. Or we have services, and that's how we ended with a bunch of microservices. And services have a strong boundary in that you cannot call the insides of a service. You can only call through the public interface. But they raise a bunch of issues related to distributed architectures, a topic on which we did a full video, and you can see the kind of trouble you can get in once you go into distributed architecture domain. So the important thing there is we still don't have a kind of strong boundary module thing that is a first-class citizen in our programming languages. People are working on it in Java, in C++, but it doesn't seem to go very fast. I think that would be the most important thing. So anyway, this is, let's say, a short answer, an overview of the whole thing, but I have much more things to talk about. Let's look first at what we will talk about. We'll talk first about context, then about testing strategies, then usage of test doubles. In terms of context, we will talk in a specific context. It's important to establish that test-driven development and tests, actually, because the question was more about tests, tests add value in a specific context. For example, if you are writing something that experimental, you are trying to learn how to do a specific thing with a specific library. In that case, I might use tests sometimes, but those tests are meant for learning. So I might use tests that show, if we take, let's say, the zip, I think is gzip library. It's an open source library that compresses files using the gzip algorithm, which is very similar with the zip algorithm. So I might first write a series of learning tests, a test that shows me how to create a file, a test that shows me how to add files to the archive, how to save it, and so on. Those are not necessarily tests that would have a search or something like that. They are more like if you were doing like small functions that, or if you're run like in a command line, in a REPL, experiments. These are the kind of things that I would write in these kind of learner tests. And some of those tests I might keep up for later in order to show my colleagues, look, this is how you use the zip library, the gzip library. These tests prove how you can use them, but they are not part of the code base that we are working on. They are more like, you know, things that you can run in order to and look through in order to learn, and maybe copy from, in order to learn how to use the specific library. So I might run some of these tests. Similarly, if I'm learning a new programming language, I might write some tests that show me how various things in the programming language work, usually self-contained, but not more than that, right? So this is one case. When you are writing experimental code, probably tests, okay, they might serve other purposes, but they're not the kind of purpose that we are talking about. Another place where tests might not be that helpful, I had to write migration scripts in the past when we were migrating from a third party to another third party doing the same thing, for example, CRM. And so I had to export data, write some code that would take the initial data and then maybe change it to the new format, or maybe just upload and call directly different services, or structure files in a certain structure so that I can upload them later, and so on. And for some of these things, I might write some tests, but definitely not 100%, because some of this will be difficult to test. And also, I was a single developer, and also it was a script meant to be run once. Of course, if it's a script meant to be run once, what typically happens with these migration scripts is that you run them, you see if there are any errors, then you visually inspect the thing, and you kind of run them separately from, let's say, in a, how would you say, without creating any real data, as a dry run kind of thing. Kind of log everything, look at the results, see if there's anything that's really not working, and improve on that, and then run on the production server, on the production system. And you'll probably need to run 2 or 3 times, because some of the assumptions that you made are not correct. And first time you'll manage to go 80% of the way, and then you need to make some changes for the last, for the next 5%, and then for the next 5%, and so on. It kind of works like that. So in this case, I wouldn't write, I would write tests just minimally and just for my own, to help me understand what I'm doing, or to help me remember what's going on in a specific parts of code. Also, if you never need to change that code, you probably don't need to do that. So in order for the discussion to make sense, We will talk about non-trivial code bases, more than 10,000 lines of code, more than one person working on it. Why 10,000? It's rather arbitrary. It can be 2,000, can be 3,000. If we assume more people working on it, if you have, let's say, 5 people, it's likely that the 5 people will cover, more or less will know different parts of the code. And so it would be easy to cover more or less 10,000 lines of code. It doesn't mean that you shouldn't write tests if you know your code base will, if you are now starting and you know your code base will grow after 10,000, more than 10,000 lines. It's better to start now than later. Always, it's better to start in the beginning. But this is, I think, where it really hits you, that you don't have tests. Multiple usage, so it's a product that's used and it has a need for change. So let's talk a typical, let's say, a typical product. It can be consumer, it can be enterprise, it can be B2B, but it's something that is used by real customers, hopefully, and or by internal users, it doesn't matter. But it is large enough and it has a team behind it. Now, if there's only one person working on it, there's also only as much as you can remember from the code. After it passes a certain threshold, it's very hard to remember what's going on in that part of the code. But maybe if you keep a consistent style, you might be able to get away without tests for longer. The issue here is once you want to add a second person in the project, you will have to teach them everything. So it's not, say, the best way of doing that. It's better to have tests. All right, so let's look at a few testing strategies. And on the edges, we have the one strategy that was used a lot while I was starting as a programmer, which was user testing. Basically, write your code, zero or some testing, release it, and users will tell you if there are any bugs, and then you'll fix the bugs and so on. This, I think, is still used, and it makes sense in certain contexts. If you have a very specific community you are addressing, if you know everyone in the community, it might be a way to sort out various things in your product, particularly when you're trying to figure out user experience or value for customers and so on. So there is a certain tolerance to bugs that users have, particularly when they know that what you are doing is very specific, catering to their needs. So yeah, it can be a valid solution in very limited contexts. Now, the other extreme to this is when you say, I want to have 0 bugs found by users. And by bugs, I'm going to be very specific here. We don't mean small things like, a label is slightly misplaced, or there's a typo, or things like that. What we mean is really things that are either blocking a user from doing something or crashing, So So either typically any kind of bug where I'm trying to do something as a user, but it doesn't let me do anything. It doesn't let me finish my task. So between these, there are a bunch of strategies that you can do. And the first one that many organizations did was to create a QA department and do manual testing. So we hire a bunch of testers and developers do their thing, and after the code is developed and you have a build and you decide that you need to start testing, you send this to the QA department, which starts doing a lot of manual testing and giving you bugs and so on. I won't go a lot into it, but this has created a number of issues. Particularly, I think the most important one is the one of responsibility, where developers felt that they weren't responsible for delivering code without bugs. It is more like, testers' responsibility to catch those bugs, because we just cannot write code without bugs. What do you want from us? It's just programming. And this is a myth that's still very pervasive. And that goes away once developers have the responsibility for fixing most bugs, not all of them, but most bugs. And then what you have is the next level. Let's say we have Scrum teams. This is very common nowadays. And we call them teams, although they are not really teams, but we go through the motions and we put in a team, let's say 2 developers, 3 developers, 1 Scrum Master, we have 1 product owner, and 2 testers, or 4 developers and 1 tester, whatever combination you might have there. Maybe some business analysts and so on. So now what you are having is a mix of manual and maybe you start doing some automated testing, but the automated tests are written by testers. So basically what you have is not a team, but you have programmers doing their own thing and then giving their code, their results to testers, hopefully in the same sprint, but most commonly not in the same sprint, like 3 sprints later or something like that. And testers take that and start testing and write some automated tests using their own frameworks and so on. And this is, okay, it's slightly better, but it's not very effective. It's not very effective because we are catching the bugs too late. We don't have a fast enough feedback cycle. And then the next level is automating most testing using developer tests. And by developer tests, I mean tests written by programmers. Programmers write their code. With the code, they write also tests that cover that code. And in doing so, they ensure that, one, you don't have regression. So when you change things, you later on, you will catch potential bugs before they actually happen. 2, that the behavior that they have implemented is actually the correct in terms of what should have been implemented. But this is not enough. You also need to catch remaining bugs with manual exploratory tests. So even if you have 100% coverage on behavior, and you have a bunch of different levels of tests, like unit integration and so on. Although these terms start to become fuzzier and fuzzier with time. What happens is that you might still have some weird issues, and this is where testers are amazing, because testers can imagine a bunch of weird scenarios. Some of them that we talked about also on this channel, many of them are related to time and date and time zones and things like that, but there can also be some other things like, clicking a button 10 different times, or introducing a bunch of different data in different orders and seeing if there's any problems, so on. Or going somewhere, doing something, going someplace else, doing something, and so on. And this is where it's really, it takes some imagination. So it's up to you where you want to be on this line. And when I say, well, up to you, it's probably up to your managers. But each of these is actually a valid approach in various scenarios. Like you might have 100% manual testing done by QA department. Well, I don't like the QA departments, but still, there might be a valid solution for specific products. If the product is very small, if you have teams organized in a certain way, or very specialized testers or very specialized products, I don't know. I think still the most effective one is automating most testing through developer tests. And I realize I left one out of here, but because it's more weird in a way, and that is relying on monitoring to catch bugs. I think this is a more common approach nowadays than it was many years ago. Nowadays, due to the increase in infrastructure automation, increase in monitoring tools, and even, AI, and we'll discuss about this a little bit later. It might also be a solution or a strategy. But in my mind, this strategy is complementary to having the developer tests, because developer tests will remove the first and most common types of bugs. Things like null reference exceptions should never reach the production environment. And once you avoid having this kind of basic mistakes, then yeah, you might add on top other things like smart monitoring and stuff like that. Okay, so this is kind of an overview of the landscape of testing strategies. And really the question here is, how many bugs do we want users to find? And how much are we willing to pay to do that? Because the next thing is about effectiveness. What is the cost of a bug? And I think the cost of a bug has a few different components. On one hand is reputation of your product, of your company, of your team, and user trust. If I'm using a product and I see it has a bunch of bugs, I might say, okay, I'm gonna give up. I might even tell other people, this product, not that good. It might be good, but it is very buggy. By the way, one type of one type of product where things seems to be different nowadays is games. It's more and more common to release games with bugs, to the point where releasing games without bugs is a real event in the gaming industry. Like the latest surprise here has been the game Baldur's Gate 3, which was released after very long early release period where they kind of tested with users and so on. It was released with almost no major bugs. But typically what happens is even very important games are released with bugs, and then they kind of get a 0-day update and a few later updates. So there seem to be places where this works. Okay, I'm not sure how long it will work, but they work. Another cost, the second cost, is the cost of finding, fixing, retesting, upgrading. And this is different for every type of product. Once you get a bug report, somebody needs to look at the bug report and needs to prioritize, sort, assign. A developer needs to start investigating. They need to find where the bug originates. They need to find a fix. They need either to retest it or to send it to QA for retesting or involve testers. And then you eventually need to include the fix into a build and deploy that build. Now, depending on your product, each of these costs is different. For example, if you have 10 million lines of code, it might be more difficult to find and to fix the bug. If you have 1,000 lines, probably easier to find and to fix. Retesting, that depends a lot on the complexity of the bug, right? Upgrading, this is something that we as developers rarely think about, but think about it this way. Okay, if you're doing a web-based kind of thing using cloud, then it's easy. You just hit a button, run a script, upload the Docker image, whatever. You just go through continuous integration and it works. But if you are on embedded devices, you need to deliver this download to potentially millions of users over the air. If this is in a car, you might need to call the car to the service in order to deploy the update. So on. So things are very different. And in some cases, this is very costly, might incur costs. So depending on where you are, okay, maybe this cost is low or this cost is high, but one thing that we can intuit from all this is the faster you find the bug and fix it. So if you can find the bug and fix it in your environment before releasing, the cost will go low. And the cost will be lowest when you as a developer find the bug in the code review or pairing with a tester or while writing your tests. It will be much, much cheaper to do that than to go through this whole process. And let's also, I forgot of putting this here, but there's an opportunity cost. The opportunity cost is while you are working on fixing bugs, you are not working on adding more features. So if 80% of your development capacity is focused on bug fixing, it is not focused on developing features. which means that you might go beyond your competition after a while. There's the opportunity cost. And then there's the motivation hit. The motivation hit is for developers. Do you enjoy working on bugs? Because personally, I don't really like that. I mean, I like it occasionally when it's an interesting puzzle. But most of the times, what I like to do is to add value for users, add features that work for people to use and to save them money, time, and and so on. This is my ideal place where I want to be. So whenever I get a bug, I'm not happy. I'm not happy about it because I'm thinking, oh, I could have done something different with this time. But also, not only I could have done something different, I can't help thinking that if only I could have done better in the past, then this might not have happened. And I'm always trying to learn from every bug that I am getting what I can do better next time. Because it's not worth thinking about the past, but it's worth looking at what I'm learning from this bug and what I missed and what I could have done better. Well, what I should do better next time when I'm developing something similar. Okay, so these are some costs. And the question is, are all these costs worth it? And now try to think not only as a programmer, but try to go and think about your organization. Because if your organization grows, it's likely that you'll also be happier. You might also get a raise and so on. You know, think about it in this way. Now, are tests free? No, they are not free. There's a cost to be paid for writing tests. And typically when people look and try to compare the time for developing a feature with the time of developing a feature, well, without tests, and the time of developing a feature with tests, of course, the time of developing a feature with tests is longer. But try to look at the whole picture. What is the time to develop a feature, test it, deploy it, and then fix all the bugs that you get from the users, compared to the time of developing a feature with tests? This is the correct comparison, because you need to look at the whole chain of events, not only to your short-lived task as a programmer. Okay. So if we are writing automated developer tests, there are a few things that we can do here. A few advantages. One, catch regressions early, particularly if we have 100% coverage or close to 100%. You'll never have 100%, but close to. You can catch regressions early. You can find bugs as part of the process, so you find it early on. But the most important part on an individual level is the peace of mind that you have when you change things. Typically, when we change code that we wrote, code that is in production that we wrote a few months ago, and it doesn't matter, maybe I wrote it, maybe somebody else wrote it from the team, typically you have to walk on eggshells. You have to be very careful not to break anything, not to do anything that might influence or introduce bugs in other parts of the system. The advantage of tests is that if you have these tests, and if they test the right behaviors, as we discussed in the beginning, now you have a peace of mind when changing things. And it's very hard to measure the effect of this. But what I've noticed is a few things happen. First of all, a part of your brain gets freed up because you no longer think about what might go wrong, but you only think about how can I solve the problem at hand. And you start experimenting, you run the test, you see, oh, this is breaking something, okay. So now I need to change it a little bit. So part of your brain cycles are getting freed from worrying. And also there's a level of serendipity in the sense that you might think of simpler solutions, better solutions for more complicated problems. And you can actually experiment and give yourself this freedom to experiment and try out other things because you have the tests to help you, catch any obvious mistakes, and sometimes non-obvious mistakes. Ideally, developers would have brains that would be able to completely remember and kind of model the system in their head. But in reality, after a certain number of design elements in your code, you cannot hold everything in your head anymore. So then you kind of have to go from one window to another. Think about your system as a full thing, but then you just have a small window you can look through, and then you go through each of these windows. And the advantage of tests is that they will do that automatically, and you can focus on the most important thing at the time. So this is where the advantages come in. So now let's move into answering the question. Because there's actually another way of doing this. There are basically two approaches. One is to go for asymptotic 100% behavior coverage. And I'm saying asymptotic because you'll never have 100%. There are things that are just too difficult to test. The time spent, you will be able to test them if you spend enough time, but it's not worth it. And maybe there are some things that are fundamentally untestable. There are things that are not worth testing. So we're going to go for an asymptotic 100% behavior coverage. And behavior is very important. You need to think about the behaviors of your product and not about classes, functions, and so on. The other approach is something called risk-based testing. And risk-based testing takes the approach of looking at your code base, at your architecture, and figuring out, okay, what are the parts that absolutely need to work 100% or we will lose money? These are the ones that we absolutely need to test. Now, which are the parts that if they don't work, they will be a nuisance, but, it's okay. We can live with that. And you decide whether you test those or not. And what are the parts that will either be tested by something else, or, it's very unlikely to make mistakes. Or if you make a mistake, it's immediately obvious. Like if you write something completely wrong in your configuration file, when you start your product, it will immediately tell you it just doesn't start, okay? And that is something you might not need to test. So these are the two approaches. Now, the asymptotic 100 behavior coverage has the advantage of being very simple. It's like, okay, we will just, for every user story or feature that we want to implement, we try to define the behaviors. For every behavior, we write one or more tests, and they cover the code, and then we look at the code coverage and see if there are any places that we kind of missed, and then we decide whether it's worth writing tests for those or not. And that's the general approach. It's very easy to do. The risk-based testing requires more thinking, more cooperation. It might be even more complicated with the more people there are, because you'll have differing opinions. And it also has another issue, which is you should take into account security issues as well. So when we talk about risk-based, we also need some thread-based testing, because there are things that you might need to test, like the configuration files, for security and not necessarily for making sure that the things work. So I would still prefer the asymptotic 100% behavior coverage. But if you are a small team, particularly for extreme programming teams that are like 5 people who know a lot of things about their code, and they have done test-driven development for a number of years, and each of them knows where they will make mistakes, you can count on the individuals to make this decision and say, okay, so I'll test that part, but I won't test that part because that part is, basic code, impossible to get wrong. Maybe the methods are very small. Everything is very readable. Maybe you just have a long configuration class that has getters and setters on only getters. And okay, if you make a mistake there, whatever, you'll figure it out soon enough. Right? So it's worth considering this, but honestly, I will only go with risk-based testing once you have lived through 10 years of test-driven development and actually practiced it correctly, because it gives you a completely different perspective on what mistakes can be made, and more interesting, what mistakes you are more likely to make. So this relates to the final thing, which is tests needs to be smart. Test behaviors, not classes and methods, we talked about. Never test private methods directly, or always write a test for a bug. If you find a bug, first thing, write a test that shows that the bug exists, then solve the bug, and the test should pass. Why? Because it's very likely that you will repeat the mistake, and you might have regressions later on. Maybe somebody will do a wrong merge or something, and you will end up with the older version, but you still have the tests. Okay? And my personal recommendation is to use the Chicago style. I'm not going to delve into it. If you want me to delve into it, test-driven development can be done in a number of styles that are defined by whether you are going outside in or inside out, by whether you are doing state-based tests or behavior-based mocks, behavior-based tests, and whether you are using stubs, mostly stubs or mostly mocks. So there is a style that's called the London style, which is outside in with a lot of mocks. But you can have this other style, which is you think about the state, what is the value in, what is the value out. You stub only when needed. You use almost no mocks. You only use mocks when you are calling classes that are commands or services that are commands and that don't return a value, fundamentally, and that you don't want to test as part of the same behavior. But there's a lot more to delve in here because you can do a number of different variations here. So look into the Chicago style. This is the one I would recommend for modern testing. Now, question. Let's go back to the original question. Do we really need to test everything? And my answer would be, it depends, of course, based on everything that we've seen until now. At a minimum, test the behaviors that will cause damage when not working. And damage can be time spent debugging, loss of money, loss of income, user unhappiness, you name it. However, asymptotic 100% behavior coverage reduces your fear to improve things, which can lead to better solutions and improve motivations. So think about it this way. Yeah, I'm writing. You can think about tests as a core, as a chore. Think about tests. You can think about tests as something, oh, now I wrote the code, now I really have to write the test. Oh, that's awful. Oh. Or you can think about tests as, that's one of the good things about test-driven development, as a question, as an exploration. You start from the behavior and, okay, you get the task and then you think, okay, what's the first thing I need to do about this task? And then you write your test. And the test is failing, and then you implement the code, and suddenly now you have a green light, and it's like, oh, this is working. And if you do this again and again and again, it's fairly motivating because you keep seeing things go green, and you know that things are improving, and you know that you are building on solid ground, which is a very nice feeling. But the main motivation here doesn't have to be writing code, but it has to be solving problems. TDD is a way of solving problems through an incremental method of writing, of designing code. Now, opinions on stubs and mocks. Test doubles. And there are about 20, 30, maybe more test doubles. We most commonly use stubs and mocks. However, there's a book by Gerard Mezaros, which somebody we had on this channel. He had some very funny stories. And he wrote a book about testing patterns. And in that book, you'll find more types of test doubles that are very useful for different types of problems. So, but we'll focus on mocks, stubs and mocks. Stubs and mocks are very useful for specific situations. Know when to use them, don't abuse them. So stubs are very useful for replicating situations that are difficult to replicate. For example, how do you test for the leap year, for 29 February 2024, by the way. Next year, leap year, make sure you test your code. How do you test for that? Well, there's an easy way. You have an interface for your clock, and when you ask the interface for the current date and time, you stop that, you return the value of 29 February 2024, and see what happens. So it's as simple as that. They are very useful for this situation. Mocks are very useful when you are calling commands that don't return values. It's like do something, but it's a void method. It doesn't tell you anything. And you want to have a double for that, but without actually doing anything. Maybe writing a file to the disk or something like that. There are a number of other situations in which stubs and mocks are useful, but these are, let's say, two core situations, and they are really useful. Another example for stubs would be random data. Maybe you have a random number generator in your code. How do you test for that? Well, make a stub, return the data that you want. That's as easy as that. So know when to use them, don't abuse them, and that's just it. Now, my preferred way, and I won't be pushing this because it depends a lot on your level of knowledge in testing, in automated testing. It depends on your personality up to a certain point. It depends on the product you are developing. It depends on the programming language sometimes. My preferred way is behavior-centric tests, state-based, outside in, with a very few mocks. And you'll notice this is not necessarily Chicago style, it's a bit of a different thing, but okay, that's what it is. We can explore this more. Now, with all this discussion with tests, it's worth mentioning that tests are not enough. You need to do more in order, if you really want to reduce bugs. Tests will catch the most, I wouldn't say the most common bugs. It's more like they will filter a lot of potential bugs, okay? But not all of them, because you still have some potential bugs that are happening due to production things. What happens when your hard drive doesn't work, or when one of the servers goes down, when one of the services goes down, and so on. So, and what happens if you have multiple products that interact with each other, or multiple services that interact? Things can get really complex. So in order to deal with that, the general approach is to reduce feedback cycles, which means try to put things as fast as possible in production and or as close to production as possible, and inspect them, see what happens. And a few things help here: infrastructure automation, because this helps remove some configuration bugs, security issues, continuous delivery, because this helps take into production things very quickly. Monitoring, because when something happens, you'll know before, ideally before users. You should be able to tell before users when something is not working properly. Then there's chaos engineering, which is a very weird idea, but it's basically, if we have a complex system in production, let's try to randomly stop things and see if what happens, because this is how we find potential issues that we can then fix. And the ideal that we are striving for is self-healing systems. Self-healing systems would be more likely done through a combination of tests, monitoring, smart actions, and AI. So for example, you might have monitoring. Well, first of all, you write tests, remove a few of the common bugs, or many of the common bugs. Then you take into production. Your tests also become a monitoring device. So you keep running those tests in production, but you also run other things and kind of look at what's happening with the data. And you have trends, and maybe you have some smart agents that analyze that data and those trends, and when they see something go wrong, they decide on a smart action. And like, for example, okay, let's clear the hard drive of that system, or the most common one would be, let's restart it, or even, let's redeploy, let's deploy another instance, remove this one, and move everything to the new instance. There are a lot of things that you can do here, but the ideal thing would be for complex systems to kind of self-heal based on signals they get from inside. Okay, and now let me close with an experimental way, a way that I'm experimenting with, and I think it makes a lot of sense. I think this pattern would apply to a number of web, desktops, maybe some mobile applications. And the fundamental idea would be to split your application into small modules that have strong boundaries, but not necessarily services. We need better module support in our languages. Each module would follow the functional core imperative shell paradigm, CQRS, so command query separation, screaming architecture. So the structure of the module should tell you what the module does at the first glance. Each module will also be self-testing. So for example, if these modules are deployed as URLs, you would have a /tests or /module/test that would run all the tests for that module. Yes, and even in production, if you want to, you might restrict that so that, people don't run it, but it might be for your internal use. Then you would have risk-based testing on every module, although, to be honest, if the modules are small enough, it's easy enough to do 100% behavior coverage. It's more complicated between modules, and this is why I'm still working on kind of integration testing strategies. So this is what I am working on right now. It's a kind of architecture that I find really compelling, and I'm using the nullable tests approach pioneered by James Shore, which we also did a video on, but I'm kind of trying it out and see how it works, and it's very, very interesting. So with this being said, I hope this was useful. We started from two simple questions. Do we really need to test everything? An opinion on stubs and mocks. And we ended up talking about a number of different things, because in reality, this question is the tip of an iceberg, and you need to look at the whole iceberg to understand where this sits. So I hope you find some useful insights in what we have discussed until now. With this being said, let us know in the comments if you have any other questions, and who knows, we might do another full-length video on this or another shorter explainer video answering your question. Thank you kindly for the view. Remember that we are doing this every week, so watch for another video next Saturday. And until next time, remember to think, design, and work smart.